All right, welcome back, everybody, to Accuplacer Math Crash Course, Day 2, Part 2. We've got Kiesia with us, and we are answering some more questions. The level of difficulty can be bumping up a little bit here, some of these questions, but that's all right. We're still thinking in terms of logic and estimation and really just understanding these questions. So go ahead and read question number 9 for us, please, Kiesia.
Water runs from a pump at a rate of 1.5 gallons per minute. At this rate, how long will it take to fill a tub with a 150-gallon capacity?
Yeah, capacity, right? Do you know what that means when it says 150-gallon capacity? You know what that means?
I just think about a tub full of water.
Yeah. Well, I don't know if it's full of water right now. It's going to be. But capacity just means how much it holds. Does that make sense?
Okay.
It's helpful knowing that, just knowing what all these terms mean here. So we've got a tub. It's got 150-gallon capacity. It holds 150 gallons, okay? And the water's running from a pump at a rate of 1.5 gallons per minute. 1.5 gallons per minute. Does that make sense so far?
Yes.
Okay, great. Again, I don't want to think about, math operations. I don't want to think about, I don't want to think about math, honestly. I just want to think about this tub. And I want to think about the water. You know what I'm saying? Let's draw a picture. Let's start there. Do you mind if I draw this tub? All right. I'm going to draw a tub. I'm thinking like a kiddie pool, probably because I have like a kiddie pool on my back porch. Okay. We got a tub. Okay. 150-gallon capacity. We'll label that 150-gallon capacity. Okay. Not filled with water yet. Or it doesn't say it is, at least. Now we got water coming from a pump, or like a hose or something like that. I'm going to draw a little hose. Right. Okay. And water is flowing, right, at a rate of 1.5 gallons per minute. Is this all making sense so far?
Yes.
Okay. Let's get into the logic of this question. Let's understand it. I want to understand the situation. I want to imagine this water flowing. All right, so if it's flowing at a rate of 1.5 gallons per minute, how many gallons are going to be in that tub after 1 minute? Let's start there. After 1 minute. And remember, the water is flowing at a rate of 1.5 gallons per minute. So after 1 minute, how many gallons are in the tub?
1.5.
1.5 gallons. Does that make sense?
Yes.
What about 2 minutes?
That would be like 2. No.
3. Absolutely 3. I mean, does it make sense why it's 3?
Yeah.
Right? It's just twice 1.5. Or 2 times 1.5. Does that make sense?
Yes.
Okay. What about 3 minutes?
6.
Double check that math. I mean, we've got 1 minute.
4.5.
What'd you say?
Would it be 4.5?
Absolutely 4.5. Absolutely, right? I mean, it's just 1.5 plus 1.5 plus 1.5. Right? If 3 minutes. Does that make sense?
Right. Yes.
Or you're like, oh, it's just 1.5 times the number of minutes. Does that make sense?
Yeah. Mm-hmm.
Once you start to think about and understand, actually, you can figure out what the operation is now. Once you're understanding it the right way. Does that make sense?
Yes, sir.
What about after 4 minutes? Tell me, how many gallons are we going to have there after 4 minutes?
6.
6, yeah, because it's just 1.5 plus 1.5 plus 1.5, or just 1.5 times 4. Does that make sense?
Yes.
So think about this for a minute. After 4 minutes, we only have 6 gallons in there. Right? We only have 6 gallons. I'll bet we can eliminate an answer choice that I know there's not going to be enough time to fill that thing up.
You're talking about D?
That looks like a lot. That looks like a lot, right? Because if we're multiplying the number of gallons by the number of minutes, which we said we are, right?
Mm-hmm.
Then D is going to be way too big. Is that clear why D is going to be way too big?
Yeah.
That would have to be like an Olympic-sized swimming pool, right? But even if you think about it logically, you've got a 150-gallon tub, and if you have water flowing at a rate of 1.5 gallons per minute, 2,000 minutes is really that thing is going to be so overflowing. I mean, again, that would be like an Olympic-sized swimming pool, I'm guessing. So I would get rid of D. There's another one I think is just too small.
A.
I think A is way too small, right? Remember, because we said after 4 minutes, there's 6 gallons. You know what I'm saying? I'm just thinking about the rate it's water flowing. After 6 minutes, there's only wait, after 4 minutes, there's 6 gallons. So after 10 minutes, am I going to have 150 gallons?
No.
No. Does that make sense? Why? That's just silly. If you understand the question, if you understand the scenario, if you think in concrete terms, A and D are both silly. A is way too small, D is way too big. Does that make sense?
Yes, sir.
Okay. At least B and C sound reasonable. 100 minutes, right? You got like water coming from a hose, pump. Something. Okay. That's reasonable. C is reasonable. I don't know what the answer is here. We're going to find out in just a minute. But remember, we said once we were just kind of playing with the numbers and kind of understanding the question, we said we just multiply the number of gallons by the number of minutes, and we find how much is in the tub. Do you think you know what the answer is?
Yes.
What's the answer?
B.
It's got to be B, doesn't it? Do you multiply 1.5 times 100?
Yes.
What'd you get?
150.
Bingo. 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 Any questions about that, Keisha?
No, sir.
Do you understand the importance of conceptualizing, thinking about the question the right way?
Yes, sir.
Okay. You're not just saying that. You really understand the importance of it.
I really understand it.
Yeah. It's everything. It's everything. It's everything. Because, a lot of students are going to be like, oh, I'll just divide 150 by 1.5. Oh, yeah. Or do something else. I don't know. I don't know what else. Who knows?
And then I saw per, so I knew that per means one, so I knew I was going to have to multiply somewhere. Multiply something.
Okay.
So.
Well, per means actually dividing, right? I mean, 1.5 gallons per minute.
Oh, each means multiply.
Yeah, 1.5, that means 1.5 gallons per divided by 1 minute. Does that make sense?
Yeah.
Yeah, so actually, really, do you understand that? Per means divided by, like, if you're going 60 miles per hour, that's 60 miles divided by 1 hour.
Yeah.
Does that make sense?
Yeah.
Or percent, right? 50%. And I think we learned this in day 1 session. 50% means 50 per 100. Or 50 divided by 100. Cent means 100, right? You knew that, right? Cent means 100.
Yeah.
Like a century is 100 years. There's 100 cents in a dollar.
Mm-hmm.
Yeah. Understanding what the terms mean is huge. Huge. Absolutely. Okay. Let's do some more. All right, question number 13. Go ahead and read this for us loud and proud, please.
What is that? Khalid?
Khalid, I think. Actually. Yeah.
Khalid? Okay. Mm-hmm. It took Khalid 90 minutes to complete 40 tasks. Which of the following is the equivalent rate?
What does equivalent mean again?
Equal.
Equal rate. Yeah, equal rate. Now let's understand the scenario again. Let's understand the scenario again. Okay? Khalid is working 90 minutes. Think about that. You know how long 90 minutes is, right?
Yes.
Yeah. How long is that? In hours, by the way. Do you know how many hours?
Hours?
What is it?
You said something about an hour?
Yeah. How many minutes? How many hours is 90 minutes? Do you know?
Well,
you don't have to know for the question. I'm just trying to think about this the right way. It's like an hour. It's like an hour and a half.
Okay.
It's like an hour and a half, right? Because 60 minutes is an hour.
Yes.
So this is 1 hour plus 30 minutes. 30 minutes is a half an hour. So that's an hour and a half. Does that make sense?
Yeah.
So it's like the length of a movie. Most movies are like around 90 minutes. Okay.
Okay.
I just want to think about it the right way. I want to think in concrete terms. Okay. And he's completing 40 tasks. 40 tasks in those 90 minutes. Does that make sense?
Yes.
Okay. Can you imagine someone? I want you to close your eyes and think about it. Imagine somebody. He's got 90 minutes. He's completing 40 tasks. So I don't know what the task is, like folding a shirt or something like that. That's what comes to mind. I don't know, because maybe it takes like a minute or two for me to fold it, but like something like that. I could fold 40 shirts in 90 minutes if I don't get too distracted. Does that make sense?
Yeah.
Okay. So we're trying to find an equivalent or an equal rate. Okay. Here's my question. I just want you to estimate. How long is it taking him to complete a task? just want to think about it the right way. How long does it take him to complete a task? Roughly. Because I don't know the exact number, but like roughly.
To complete one task, how long does it take? I don't know. About a minute, I guess.
Well, if it was 1 minute, then he could do if he was doing one task per minute, then he could complete 40 tasks in 40 minutes, right?
Or less than a minute.
Well, if it's less, then he could do 40 tasks in like 20 minutes.
Oh.
If it was less than a minute per task. Does that make sense?
Yeah.
Here it's taking him 90 minutes to complete 40 tasks.
Goodness gracious.
Do you understand my question? Do you understand my question?
Yeah. I'm trying to think about if I was doing these tasks.
Yeah, that's why I want you. That's exactly how I want you to think. 90 minutes to do 40 tasks. How long does it take him to do one task?
I don't know. It's gonna take me a really while.
Is it taking more than a minute to do a task?
Yeah.
Yeah, it's taking more than a minute. Is that clear? That's taking more than a minute?
Yeah.
Because he's not doing, the number of tasks is not equal to the number of minutes. The number of tasks is less than the number of minutes. So it's taking more than a minute per task.
Okay.
If it was taking 2 minutes per task, right, let's just estimate. If it was taking 2 minutes per task, how long would it take him to do it? If it was taking 2 minutes per task, and he's got 40 tasks.
I don't know. I probably had to see him work this out.
Okay, no problem. Let me put it in these terms. If it takes him 2 minutes per task, it's going to take him 80 minutes.
Oh, okay. I see what you did there.
Do you see what I did there?
Yeah.
Yeah, right? It would take him 80 minutes. If it took him 3 minutes per task, it would take him like 120 minutes. Because it's just 3 minutes for every task. Or 3 times 40. If it's 2 minutes per task, it's just 2 minutes for every task, or just 40 times 2. Does that make sense?
Yeah.
Okay. Real basic. But again, we're just trying to think in as most concrete terms as possible, trying to understand this. I don't know if drawing a picture would be super helpful, because we were talking like drawing 40 tasks or something. That would be really tricky. So I just want to think about it the right way here. Okay. So, but here it's not taking him 80 minutes per task, it's taking 90 minutes to do, it's taking 90 minutes to do 40 tasks, not 80 minutes. So it's like a little bit more than 2 minutes per task. A little more, right? Because 2 minutes per task would be 90 minutes. So a little bit more than 2 minutes per task would be, 2 minutes per task would be 80 minutes. So a little bit more than 2 minutes per task would be 90 minutes. Or could be 90 minutes. Does that make sense?
Yes.
Okay. Great. We know it's taking him, and I'm going to make a note of that. It's going to be a little bit more, 2 minutes plus per task. I'm just going to make a note of that so we don't lose that. I apologize for the terrible handwriting. All right. 2 minutes plus. So let's look at the answer choices now. We're trying to find the equal rate. If he's doing one task in 2 minutes, right? And that might be a better way. In fact, I'm going to express it that way, because they're talking about the task per minute, not the minutes per task. So let me erase that real quick. He's doing one task in 2+ minutes. Okay, does that make sense? It's the same thing. 1 minute, one task in 2+ minutes.
Yes.
Okay. Is it possible that he could do 10 tasks in 0.9 minutes? Does that sound reasonable?
No.
No way. Why not?
Because 9 is just 0.9. It's like really, really fast, right?
It's really what?
Like really, really fast.
That'd be so 10 tasks in 0.9 minutes. Like 0.9 minutes is less than a minute. It's just a little bit less than a minute, but it's less than a minute. And if it takes him 2 minutes to do one task, is there any way he could do 10 tasks in less than a minute?
No.
No way. Does that make sense? Why? That's just silly.
Yes.
That's totally silly. That's way too fast. Think how fast. 10 tasks in a minute? He's doing like a task every 6 seconds. He's flying. It's not A. What about 10 tasks in 2.25 minutes? It's just a little more than 2 minutes. Could he do 10 tasks in 2.25 minutes?
No.
No. Why not? Tell me why not.
Because you can only do one task.
Yes. Kiesia, you are understanding this. You are understanding it. How obvious is it when you understand the question?
Yeah, it is.
It is really obvious. Now you got to understand it. But if you do, A is silly, B is silly. If this is as far as you get, you've got a 50-50 shot between C and D. Those are good odds on a really tough question like this. This is not an easy question. Not an easy question. Okay, what about answer choice C? Could you do 10 tasks in 9 minutes?
No.
No. Why not? Tell me why not.
So 9 minutes, like, I would say it'd be like almost a minute to do like one task.
Yeah. And it's taking them longer than 2 to do a task. That's less than a minute per task. Do you see that?
Mm-hmm.
And it takes them more than 2 to do 1. No way is it C. I'm guessing it's D. Hold on, let's think about logic. Could you do 10 tasks in 22.5 minutes?
Yes.
That sounds reasonable, right? Because remember, we said it takes him just over 2 minutes to do one task. So to do 10 tasks, just multiply it by 10. So 20, something a little bit bigger than 2 by 10 is going to be like around 22. That's reasonable.
Mm-hmm.
That's reasonable. How much math did we do there? No.
Well, no.
I mean, not much. Not much. We didn't do an operation. We didn't set up a proportion. We didn't have any fractions flying around. You know what I'm saying?
Right.
It's just understanding the question. Okay. I know it's tough. Just because you're not trained to think this way.
Yeah.
You're not trained to think this way in school. School sucks. Let's be honest. School just sucks.
Yes.
It just does. But it's like you get to tap into all your common sense and all of your experience, a lifetime of learning, a lifetime of completing tasks, right? Or baking cookies or making pancakes or something. You've got all that experience and you get to tap into it. That's all this is. That's all this is. It's disguised as a math test. But if you use logic, you got it. Any questions?
No, sir.
All right. We'll get to the math. We did a little bit today. I'm not saying don't do math. Boy, if you can avoid it, you'll be in good shape. A little bit similar here. Go to read number 3 for me, please.
What is the number of grams in 500 kilograms? 1 kilogram equals 1,000 grams.
Okay. Again, the temptation is just to jump right to an operation. Don't do that. Don't do that. Do you know how much a kilogram is?
Oh, is it like small?
A kilogram. Well, do you know how much a gram is?
Don't know, to be honest with you.
No. Well, here, look, and this is important. This is part of the game here. I want you to understand what a kilogram means.
Okay.
A kilogram is, I'm fairly sure, is bigger than a pound. Look, I'm a good red-blooded American. All right, so I know the English system. I know pounds and ounces and all that, right? So I know how much if I buy a pound of sugar at the store, I know what that looks like. I know what that feels like. Right? If I gained 10 pounds, during say a quarantine, I know what that looks like. I know what that feels like. You know what I'm saying?
Yes.
I didn't. Just for the record, I did not. Actually, I probably lost weight, but that's not important. Anyway, a kilogram is more than a pound. It's like twice a pound or something like that. It's just more than a pound. Something 500 kilograms is big. Okay? That's big. It's like 1,000 pounds. Okay? That's real heavy. I don't think I could lift. I know I can't. 500 kilograms. I need to double check. Yeah. Roughly a kilogram is twice a pound. Roughly. That's a big thing. 500 kilograms. I'm going to draw that.
Okay.
I'm going to draw it. Right, it's like a 500 kilogram weight. 500 kilograms. Okay. It's like a horse.
Okay.
It's big. Okay.
Yeah.
It helps to know what that means. Okay. Now the question is, how many grams are in 500 kilograms? Do you know how much a gram is?
No. What happened? Is it on your cheat sheet? Or no?
You know, it's not. It's not. Maybe I can always add. I mean, heck, I can add it. I may do that.
I was gonna freshen up on that part.
What's it? Yeah. Look, a gram is small. A gram is small. Okay, I'm not going to tell you why I know so much, about what a gram is. I'm not going to tell you. I'm not going to tell about my college years. But a gram is pretty small.
Okay.
Woo, said too much. All right. But a gram is very small. But a kilogram is pretty big, and 500 kilograms is really big.
Right.
Does that make sense?
Yes.
Okay. And the question is, how many grams are in 500 kilograms? Well, what's bigger, a gram or a kilogram?
A kilogram.
A kilogram's a lot bigger. In fact, a kilogram is 1,000 grams. They tell us that right there. So if I'm just looking at the answer choice, there's a couple answer choices I'm like, there's no way it's going to be that. You know what I'm saying?
Mm-hmm.
Which ones could you get rid of?
I'll get rid of A.
A for sure. What else can we get rid of?
B.
B for sure. B for sure. Right? And think about it. Like, it could, if we're talking about, look, 1 kilogram is 5,000 grams. So if it's B, that would only be 5 kilograms. You know what I'm saying?
Right.
That would only be for 5 kilograms, right? 5 kilograms would be 1,000 grams. Does that just logically make sense? Why 5 kilograms would be 5,000 grams? Yeah. So it's not A or B. It's between C and D. It's between C and D, just logically. When you understand the question. Okay? I'm cool with you. If you need to just guess at this point, great, whatever. It's not too bad. If you were I'm just curious. If you were going to guess, what would you guess? Is it C or D?
D.
I think it's D as well. I think it's D as well. Why did you pick D?
Well, you can multiply, and then, if not, then I probably just would have counted all the zeros up there.
Yeah, count the zeros. You can count the zeros, right? We've got 5 zeros. It's 5 zeros in the answer choice, absolutely. Or you could be like, well, 50, right? If 5 kilograms, again, just like kind of working our way up. If 5 kilograms is 1,000 grams, then 50 kilograms would be 50,000 grams.
Right.
Does that make sense? Why 50 kilograms would be 50,000 grams?
Yes.
Okay, but that's answer choice C is for 50 kilograms, not 500. So it's got to be D, which it is. Now we know the operation, right? You're literally just multiplying the number of kilograms by the number of grams. Now we know the operation. But I guarantee kids are going to pick A because they're going to divide 500 by 1,000. But they're not thinking about the meaning of the question, or the meaning of a kilogram, or the meaning of a gram. But if you think in those terms, again, this has got to be a lot of grams. And if you're just going to guess, I'll guess a really big one. You can just understand that. Does that make sense?
Yes, sir.
Cool. 17. Line prep.
The elevation at the summit of Mount Whitney is 4,418 meters above sea level. Climbers begin at a trailhead that has an elevation of 2,550 meters above sea level. What is the change in elevation?
Mm-hmm.
Elevation to the nearest foot between the trailhead and the summit. 1 foot equals 0.3048 meters.
Yeah. Real quick, I want to go back to the previous question. I'm so sorry, because I realized there's something I want to teach you real quick. No, do I want to teach it to you? No, we'll do it on this question. We're not going back to the previous question. We're going to focus on this one. Okay. I'm going to teach you something called conversion units on this question. Okay. Let's do this. Because I'd rather solve the other one's just logic. There's so much information in this question. Okay, let's break it down and let's draw a picture. Okay, that's going to help a lot.
Okay.
Read that first sentence of the question for me again, please.
The elevation at the summit of Mount Whitney is 4,418 meters above sea level.
Okay, let's just understand these terms here. Do you know what elevation means?
Yes.
What's it
It's
mean?
like going up.
Going up, how high it is. Absolutely, right? It's the elevation at the summit, and the summit means the very top, the highest point of Mount Whitney is 4,418 meters above sea level. Okay, so I'm going to draw a picture of this mountain. Okay, there's the mountain, little snow cap on the top, right? We'll make that sea level right there, right? Does that all make sense?
Mm-hmm.
And the elevation of that summit above sea level, the elevation, the high point is, what is it? It's 4,418 meters, right? Because we're going to have some feet deal in this question as well. In just a moment. 4,418 meters. Does that make sense so far?
Yes.
Okay, great. Read the next sentence, please.
Climbers begin at a trailhead that was an elevation of 2,550 meters above sea level.
Okay. All right. Does that second sentence make any sense at all, or no?
Yes.
Okay. They're starting at an elevation of 2,550 meters above sea level. So like, I don't know, halfway-ish? I don't know. Something like that. So they're right here, right? Like a base camp. Does that make sense?
Yes.
And there's a trail, right? Like going up to the top. Ooh, something like that. Ooh, right? But that point is 2,550 meters above sea level. Is this making sense?
Yes.
Okay, I should probably have it up a little bit higher, actually. In fact, I'm going to do that. I really want to conceptualize. So that's a little bit more than halfway. I just really want to conceptualize this the right way. It's a little bit more than halfway. Does that make sense why that's a little bit more than halfway?
Yes.
Okay. Because if the elevation was like 5,100 meters, then that would be halfway. But it's the elevation is less than that, so 2,550 is a little bit more than halfway, which it is. Any questions at the moment?
No.
Okay, I'm going to draw a little guy climbing too, just for fun. Great. Okay, that's where we start. Now the question is, what is the change in elevation to the nearest foot between the trailhead and the summit? What are we solving for here?
What is the change in elevation to the nearest foot between the trailhead and the summit?
Yeah, so which part of the picture are we solving for?
The guy walking up to the top.
Yeah.
Where he's at and walking up to the top.
Yeah. We're solving for like that length right there. That's the change in elevation from the trailhead to the summit. That's the question. Does that make sense?
Yes.
I'll bet you can just logically look at this picture now and figure out how many meters, maybe not how many feet, because they're asking for feet. But I'll bet you can figure out how many meters it is. That's easy. How many meters is that?
Would I have to do like divide or something?
Well, you tell me.
I don't know.
Think about it logically. Look. From here to here, that's 2,550 meters.
Okay.
All right, and then from here to here, well, that's some number of meters we don't know. But we know the whole thing is 4,418 meters. How could we find the missing amount?
Divide?
Well, go ahead and do it. Try that. Divide by, let's do that. Let's do it. 4,418. Divide it by 2,550. What do you get?
1.7.
Yeah.
Other numbers.
Does that look like that's 1.7 meters?
I don't really know.
I don't think you're fully understanding I don't think you're fully conceptualizing the picture. Look at it. Look at it. Look at it. The whole mountain is 4,418 meters.
Okay.
Right? That's a lot of meters. And the trailhead is like up 2,550 meters. He's got a long way to go still. You know what I'm saying?
Mm-hmm.
Like, just under 2,000 meters to go. You know what I'm saying when I say just under 2,000 meters? Because like if you had 2,000 meters to go to the top, then the summit would be like 4,550. Does that make sense?
Mm-hmm.
Or no? It's gonna be a pretty big number. It's not gonna be 1.7 meters. Like 1.7 meters would get him from like here to like here, if that. In fact, not even that. You know what I'm saying?
So I would subtract?
I'd subtract. Now try that. Try subtracting. Tell me what you get.
1,868.
I'm doing the same thing here. What'd you get again?
1,868.
That's what I got too. And I think that's the answer. 1,868 meters. Okay. Right there. There's a lot flying around there on that picture. But does that sound reasonable, at least, that he has like 1,868 meters to go? Does that sound reasonable?
Yeah.
Okay. Now here, I'm so glad that we tried the division thing. I'm so glad. Because this is where that common sense, you can tap into that common sense again. Don't just get a number and be like, well, I guess I'll roll with that. Like, you got 1.7 meters for him to go to the trailhead to the summit. That's way too small when you think about it with common sense. When you think about what that value means, right? Don't just look at a number and be like, that's what I got. You know what I'm saying? You're like, is that reasonable? Mm-hmm. And if it's not reasonable, which it isn't, right, when we got 1.7 meters, you know you did the wrong operation. So you can use even when you're doing operations, you can use your logic to check the operations. Does that make sense, Keisha?
Yes, sir.
Yeah. Never lose that logic. Don't just go into operations mode and just start crunching numbers. Just plowing through doing, I'm going to multiply, I'm going to divide, I'm going to subtract. What did I get? Anything match up? You know. Check it. Like, is that even reasonable? Okay. Do you see why 1,868 this looks reasonable?
Yeah.
It does. Because it is. Okay. Now, remember, in the question, they're asking us for the change in elevation, the change in height, right, from the summit, or from the trailhead to the summit. But they're asking for that in feet, not meters. Okay? Feet, not meters. Do you know how much a meter is?
No.
It's like a yard. A little bit bigger than a yard, I think. No, wait. Yeah, it's a little bit bigger than a yard. Maybe a little bit. I don't know. I know. I don't watch a yard. Do you watch football?
No.
You don't watch football?
No.
What do you watch?
Oh, no, I just go on Netflix.
All right. So we're gonna talk about yards with football, but okay. A yard is like 3 feet, and a meter is like 3 feet.
Okay.
Okay, it's helpful to know. Okay, it's helpful to know. And notice they tell us that a foot is 0.38 or 3048 meters, whatever. Okay, look, we know the number of meters. I'm gonna scroll down a little bit. We know the number of meters. The number of meters is 1,000. Oh, what have I done? We know the number of meters is, what did we say? 1,868 meters. Okay. Well, we need to turn that into feet. Is that clear that we need to turn that into feet?
Yes.
Okay. And by the way, don't worry if you're like, oh, I don't know if I could do this question on my own just yet. That's okay. Listen, you are going to practice these questions. You are going to practice them. You understand, Kiesia?
Yes, sir.
These exact questions. For the homework, I'm going to send you a link to the homework document. You're going to practice all these on your own. And if you get lost, you're like, oh, I forgot how to solve it. Go back to the recording in the video.
Okay.
And redo it on your own. And practice and practice and practice. And that's going to be the key to your success. You've got to practice. Okay. But if you practice, do you think you get better at it?
Yes.
100%. How could you not? Okay. So don't freak out right now. Don't freak out right now. You're going to practice this. And you're going to watch the recording again and again and again if you need to. Whatever it takes to understand.
Okay.
Okay. All right, so we're good now, right? Does it make sense why we know it's 1,868 meters? We're good?
Yes.
Let me introduce you to my friend called the conversion unit.
Okay.
We're going to turn those meters into feet. Okay? Here's how you do conversion units. Conversion unit is just a fraction. So we're going to multiply that 1,868 meters by a fraction. Okay? Here's what we're going to do. Here's the fraction line. Okay? And in the numerator, we want to go into feet. Okay? Always put the unit you want to go into in the numerator. Going into feet. And the unit you want to go away from, we're going away from meters into the denominator. Meters in the denominator. Does that make sense?
Yes.
We're going to go into feet and away from meters. So feet's in the numerator, meters in the denominator. Now, what the values we put in the conversion unit doesn't really matter as long as they're equal to each other. So if you tell me the number of feet in a meter or the number of meters in a feet, doesn't really matter as long as they're equal to each other. Okay? How many feet are in a meter or how many meters are in a feet? In a foot. In a foot. Do you understand my question?
Yes, I understand.
Uh-huh.
So this would be this little equation right here, huh?
Yeah, the little equation they give us. Yeah, that's it. That's it. Right, that little equation. So 1 foot is 0.3048 meters. Does that make sense?
Yes.
Okay. Now, I want to stop for just a moment and understand this. We're going to understand math. Okay, I'm tired of doing math. Doing math is boring. We're going to understand math.
Okay.
All right? Is it clear that 1 foot is equal to 3048 meters? Is that clear, that those are equal?
Yes.
Okay. What's anything divided by itself?
It's going to be whatever that number is that we divided by.
No.
I mean,
no.
1.
It's 1.
Right?
Yeah. What's 100 divided by 100?
Me. Yeah. 0.
No.
What?
No, it's 1. What's 2 divided by 2? 1. What's 3 divided by 3? 1. Anything divided by itself is 1. Is that clear?
Yes.
Okay. So this thing, remember, 1 foot is equal to those are equal in the numerator and denominator. Basically, it's a value that's being divided by itself. So that equals 1. That equals 1. Does that make sense?
Yes.
Now, I know 1 divided by 0.3048 is not 1. But 1 foot divided by that number of meters is 1. Those are equal. And now here's another question. What's anything times 1?
It'll be that number that you times it by.
Yeah, the original number. 100 times 1 is 100. 2 times 1 is 2. 3 times 1 is 3. 4 times 1 is 4. 1,000,000 times 1 is 1,000,000. Does that make sense?
Yes.
So we're just multiplying 1,868 meters by 1. So we're not going to change the value of the meters. We're not changing the length, but we're going to change the form of meters into feet. Does that make sense? How we're not changing the value, we're just changing the form. Does that concept make sense?
Yes.
Okay, that's why conversion units work. We're going to change the way it looks, but it's still the same value. It just looks a little different, right?
Mm-hmm.
Just like 1/2 equals 0.5. They look different, but it's the same value. 1 foot looks different from 0.3048 meters, but it's the same value. Does that make sense?
Yes.
Excellent. Okay, so let's do this conversion unit. Okay, so we got it set up beautifully now. Here's the cool thing. Look, we've got meters in the numerator, right? That's basically in the numerator right here, right? Because that's the same as divided by 1. 5 is the same as 5 divided by 1. 100 is the same as 100 divided by 1. So that's in the numerator. I've got meters in the numerator. I've got meters in the denominator. Guess what I can do with those units? Cancel them out. Gone. Gone. And I'm left with just feet. This is why conversion unit works. Just like we can cancel out numbers, we can cancel out units. Okay?
Okay.
So this is equal to, make some space here, 1,868 times 1 foot, and what is that?
1,868.
Yeah, 1,868 feet, right? Because feet is still there. Divided by what? So remember, when we're multiplying fractions, we multiply across the numerator and across the denominator.
Divided by that decimal.
That decimal. Yeah. 0.3048. Does that make sense?
Yes.
Punch that in your calculator, tell me what that is. That'll tell us the number of feet. I'm doing the same. You got a number of feet?
6,428. That's around that it'll be 9. So. Right.
What's the answer? You see?
C.
It's C. Bingo. Bingo. Okay. I'm not saying that's easy. It's not. A lot of steps there.
Yeah.
A lot of steps there. A lot of steps there.
But I understand the conversion part because we did that in chemistry.
Oh, good. Okay, yeah. Yeah, it was fun. In chemistry, they tend to do like convert, like sometimes you'll multiply like by 2 or 3 conversion units all at once, and that gets super messy.
Yes.
I'd say just do one at a time
Mm-hmm.
to keep it simple. But in theory, you could use conversion unit to go from 5,000 kilograms to grams as well. You know what I'm saying? You could do that too.
Yes, sir.
I don't know if I'd want to get. We could do that same thing. And I've got that on the rules for Accuplacer Math, by the way. I think I've got an example with what do I have? Do you have conversion units on here? I do. Do you see that on your screen?
Yes.
So we're a basic concept D conversion units. If you got 1.5 hours, you want to go into minutes. Just multiply 1.5 hours by 60 minutes over 1 hour. Right? Remember the unit you want to go into. You want to go into minutes. Put that in the numerator. You want to go away from going in the denominator. It's going to cancel out. Right? Hours are gone. You're left with minutes. It's just 1.5 times 60. 90 minutes.
Mm-hmm.
Does that make sense?
Yes, sir.
Okay. Very helpful on this test. Your students keep talking about having to convert units, and very, very useful. Very useful. You can also approach some of those with logic and common sense too. I want to go back actually, and I want to go over the. I keep hearing from students about conversion units. I want to go back to that 5,000. I am going to do the gram question now that we've done conversion units. See, I'm just going to clear this real quick. Remember, we had 5,000 kilograms. No, wait, 500 kilograms, right?
Yeah, 500.
And they wanted to go into grams. So multiply by conversion unit. What do we put grams in, the numerator or denominator?
You're going to put grams up top.
Up top.
That's what you want to go with.
Because we want to go into grams. Absolutely. And what do we put in the denominator? Kilograms. How many grams are there in a kilogram? Do you remember?
I think it was 1,000.
1,000. 1,000 grams in 1 kilogram. Well, now you see the operation, right?
Mm-hmm.
Kilograms cancel out. It's just 500 times 1,000. Get that many grams. I guess that's 500,000 grams. Is that?
Yeah, it's 500,000.
There you go. Yeah. That's a lot of grams. Does that make sense?
Yes, sir.
Okay, good. We may have another question. Let me see. Mean, do I want to get into mean median mode? Let's do a couple more. I'm gonna, just because this is kind of a concept that does pop up a little bit, I'm gonna look at the next question actually. Ooh, am I getting it into mean median? Yes, we are going to do that, but we're not going to do probability. Let's do mean and median real quick, and then we'll wrap it up there. Go ahead and read question number 7 for us, please, loud and proud.
The table gives the population of the 5 largest countries in the European Union in the year of 2014. Which of the following is closest to the mean population of these countries?
What are we solving for here?
What's closest to the mean population?
Yeah, what's closest
out of these countries
to the mean population? Now, do you know what mean means, Keisha?
Yes, I think it's the well, like if you or put them from this grades and add it up and divide.
Yeah. So mean is just classic average. It's just average, right? Like, you add up all the values and then divide by the number of values.
Mm-hmm.
Right? So let's say you're playing, like, soccer and you score, like, 1 goal in one game. You score 2 goals in the next game, and you score 3 goals in the next game. What's your average number of goals? Right? Well, you add up all the values. It's 1 plus 2 plus 3, 6, then divide by the number of games, which is 3, so it's 6 divided by 3. So your average, or mean, of number of goals is 2. I don't know if that, I went through that real quick. I don't know if that made, did that make any sense to you at all, what I just said? You can say no.
No.
No?
No.
Okay. No. Kiesha, I appreciate your honesty so much. Thank you. Oh, that's funny. Here, look, it's right here on the basic concept cheat sheet. Here we go. There you go. Just in case you need a refresher. Basic concept A statistics. Mean is classic average. Do you see that?
Yes.
Add up all the values and divide by the number of values. So if you want to know, like, the average temperature for some number of days, over like 5 days, add up all the temperatures, divide by 5. And that'll tell you the average temperature. Does that make sense?
Yes.
That's mean. Okay, there's other averages. There's median and mode. Median is the middle number. We'll talk about that coming up. And mode is the most frequently occurring number. That also does pop up in Accuplacer. We'll spend a little more time on this a little bit later, but I want to introduce it here. And in this question, they're just asking us for the mean. So it's just classic average. Okay? So do you know how to find, well, I tell you what, even before, it might just be easier to do the operation here. I was going to do some logic and common sense, but I think it's probably easier to do the operation. Okay. I would maybe get rid of one answer choice that I know is not the average. It's not the mean.
What, D?
Maybe, I don't know. I'm not sure, honestly. I don't know what the answer is right now. D seems small, but I think one's too big to be the average.
A?
Yeah, A, right? Like, I'm looking at the values here. Maybe we should do some graph analysis here, in fact. Which we will. But, like, Germany has got the biggest population, like 80.8 million people. Why would the biggest be the average? That doesn't make any sense. You got a lot of values below that. Does that make sense?
Yeah, that makes sense.
Yeah, it's silly. Let's do some graph analysis here. There's no title, really, but and there's what's on the y-axis going up and down? What is it?
Yeah, country.
We got country,
France.
right? Yeah. Yeah, France and stuff. France, Germany, Italy, Spain, United Kingdom. And the x-axis going left and right?
Mm-hmm.
What is that?
So that'd be the populations.
Uh-huh. Yeah, we got the country and then the populations in millions. Okay. All right. I'll bet we're just trying to find the mean population of these countries. So what do we do?
We're just going to add them all up, right?
Just add them all, and then do what? You're right. And divide by what? And divide by what?
The number of countries.
Yeah, and how many countries are there? 5, absolutely. So let's add them all up. I'm doing it right now on the old calculator. Okay. Here's what I got. I got 318.3. Did you get that?
Yes.
I just add those up and then divide by the number of countries. And that's 5. What'd you get?
63.66. So the answer would be C.
C, absolutely. That's it. That's it. And that's just knowing what mean means.
Yes.
Okay. Mm-hmm. It's just knowing what mean means. You got to know it. If they ask you a question about median, you better know what median means. If they ask you a question about mode, you better know what mode means. So again, I mean, in a sense, it's understanding what the question's asking you. It's understanding the concepts. But if you know the concepts and you know what the concepts mean, then you know what operation to do.
Yes.
Do you see the relationship between understanding concepts and knowing the operation?
Yes.
Huge. It's huge. If you understand the concept, you know what operation to do. You know. Let's do one last question. We'll wrap it up for today. Number 14. Go and read it for us, please.
The table above shows the high temperature last Thursday 5 cities A through E. If the median of the Thursday high temperature for these cities was 81 degrees Fahrenheit, which of the following could not have been the high temperature last Thursday for city A?
Okay. Ooh, okay. High temperature last Thursday. What are we solving for here?
Which could not have been the high temperature for last Thursday at city A.
Yeah, which could not have been the high temperature last Thursday for city A. So there's 3 that could be the high temperature and 1 that's not. 1 that couldn't be the high temperature. Does that make sense?
Yes.
Okay. And we know the median of the Thursday high temperatures was 81 degrees. Do you know what median means again?
Median?
Mm-hmm.
Yeah, middle.
It means the middle number. Yeah. Do you drive, Kasia?
Yes.
So do you know what the median in the road is?
Yes.
Yeah, median's the middle of the road, right? Separates the 2 lanes, going different ways.
Mm-hmm.
I literally use that to remind myself what median means. And again, it's on the basic concept cheat sheet. Check it out. Median just means middle number. Boop, right there. Okay, so study that. Know that. Okay. Now here's the deal. When we talk about the middle number, it doesn't mean the middle number in a list. It means the middle number in a list from least to greatest or greatest to least. Does that make sense? Or no?
Can you repeat that again?
It doesn't just mean the middle number. It means the middle number on a list from smallest to greatest.
Okay, yes.
Does that make sense?
Yes.
Yeah. So if I've got 3, 2, and 5, the median or the middle number is actually 3. Because if I list that set from smallest to greatest, I got 2, 3, 5. The middle number is 3, right? It's not 2 up here. It's not. Does that make sense?
Yes.
Okay. Now it says the median number is 81, which is both the median number, the middle number on the list from smallest to greatest, and it's also the middle on the list. So that's either helpful or confusing. I'm not sure which, but anyway, I just want you to understand what that means. Okay. Let's test the answer choices. Could the median, what could not have been the high temperature? So could the high temperature be 85 degrees Fahrenheit? Okay. Could it be? Let's test that. Here's how we're going to test it. We're gonna plug that into the list from smallest to greatest, and we're going to see if the median high temperature is still 81. Exactly. Does that make sense? Does that make sense?
Yeah.
Okay. Yeah. There you go. Let me do it, and we'll just do this together. So we've got what do we have here? Okay. So what's the smallest?
62.
62. And then what's the next?
81.
81.
85.
85. Oh, yeah, because we're testing.
87.
87.
And 93.
93, absolutely. So is the median here 81?
No.
No. I think we found the answer. Because the median can't be 85. Or the city A can't be 85. Does that make sense?
Yes.
Okay, let's test the others. I just want to double check to make sure we're on the right track. I don't have an answer key in front of me. I don't. Let's test the others. I want to test B. So how do we test B? What are we starting with?
62.
62, and then what's next?
75.
75.
87. Oh no, 81.
81.
87.
87.
93.
93. So could it be city B?
Yes.
It could be, right? Because that worked. It gave us the middle number.
Mm-hmm.
And remember, we're looking for the one that could not have been the high temperature. And it could be B, so B is not the right answer. That's a little bit confusing, right?
Yes.
A lot of kids are going to probably be like, plug in, test A and be like, that doesn't work, so it can't be A. But I was like, no, we want the one that doesn't work. Does that make sense?
Yes.
Okay. And if we plugged in C, we're just replacing 75 with 65, but it fits in right there. That gives us a median of 81 again, so it's not C. And if we test 55, we're just getting rid of the 65 and plugging in the 55 before 62. That still gives us the median of 81. So it's not D. We can confirm it's A. Any questions about that?
No.
Okay. How are you feeling right now?
Good. I mean, I wish I would have known this when I was taking my test. I saw that and I was like, I do not know.
Well, I'm happy to help. I'm so happy to help. I mean it. Okay, so anyway, we're going to be in touch. I'll send you the homework set at some point. Shoot me an email if I don't remember. I've got 4 kids and twins on the way. Life is busy. Oh, boy. But shoot me an email. But I'll try to get that to you soon. I'll have these recordings up soon, too. You can watch the recordings and practice. You got to practice, Keisha. You got to practice. Is that clear?
Okay. Yes, sir.
Okay. It's going to be the key to your success. Appreciate your hard work today. Appreciate your attention, your participation, and willingness to learn. Appreciate it so much. And reach out to me if you got any questions, but we'll be in touch. You have a great day, okay?
Okay, you too.
All right, thanks, Keisha.